So I'm here today to talk about invisible and visible issues in high-rise buildings. Pinhole leak is an invisible problem that buildings have, but only for a short period of time. It becomes visible once the water is starting to drip down on somebody's head. Then it's a visible problem. So you know what pinholes are. I want to explain real quick how pinholes happen. So in 99.9% of the case, the pinhole leak is from a hot water pipe. Why? Hot water in a high-rise building needs to travel long ways in order to get to every floor, and in the meantime it cools down on the way. So, excuse me, so they came up with a solution to have a recirculating system that collects the water. Once it's fed all the units, it collects again on an express riser and gets back sent up on the way to the boiler to reheat and then sent on the way. So it's a circle. That circle is going on 24/7, 365. The flow of the water, the velocity of the water is what causes erosion. So it literally, the water chips away of the inside wall of the copper pipe until you have a pinhole leak. The cold water doesn't do that because cold water is stagnant in the pipe. It doesn't move. It only moves once you use the water, but when you stop the water, it doesn't move anymore. So you have 99.9% of pinhole leaks are from the hot water pipe. These are no accidents. That's a disease. It's something that you can, there's three ways really to go about pinhole leaks. You can call a plumber and you can have him come by and replace a section of pipe. That is a patchwork. This is not that's not a real solution, because when the plumber goes away, the next day it could happen that there is just a few inches above where he fixed the pipe, there is another pinhole leak, because the whole system is affected by erosion. It's not just a little section. So the real solution here is patching is really just a solution. It's a good solution for the plumber because he has to come back more often, more frequently. There is another way. It's repiping a building. That means you call a plumbing company. They rip out all the existing copper pipes. So that means they have to cut holes in each unit. They rip out all the copper pipe and they install new copper pipes. This is a good solution. The problem with that is it's very intrusive. There's dust. There's all the drywall dust, and there's fiberglass from the insulation, and then you need to patch the holes back up. Then you need to paint or drywall and put tiles back on. So it's very intrusive. It takes a long time, and usually residents are not very happy that plumbing company is in and out for 5 days, 5 business days, or even more, until everything is really completed. And there's a third way of going about this. This is the least intrusive one. It's pipelining. The existing hot water system stays in place, even though it's eroded. It stays in place, and it is being lined. So that means instead of ripping it out, the water will be drained, and there will be the pipe will be cleaned with hot compressed air, and if needed also sandblasted to get rid of all the built-up that's inside the pipes. Once the pipe is clean, a batch of epoxy is mixed. It's a 2-component epoxy that is designed just for that solution, and will be pushed through the pipe on one end until it comes out the other end. This epoxy will dry overnight, and in the morning the water will be turned back on, and you have a new pipe within the old pipe, basically. It's basically a plastic pipe within the old copper system. Now, pipelining is the least intrusive one, and it also is the fastest one. So you have probably 20% less cost, and you also don't have the headache of it being such a big project. It's way quicker, we're way faster than repiping the system. So now I finally got the slide. The slides will just explain the process, really what it is. I'm not sure if I can get this going here. 1 second.
Can you get your presentation up?
Oh, thanks. If we can find it, it's also not a big problem. We're outside where you can see, where I can explain the real process of pipelining. I can explain it in detail outside if you're interested in how that really works, the whole thing. So that was short and crisp for me. This is it. And if you have any questions, please go ahead.
Thank you. Enough, for instance, rather than cutting pipes, to have, say, one of the vanities open, and is air pushed through so that the vapor comes all the way through the system, or how do you actually get this epoxy to go through all of the copper?
When we start lining, the epoxy is traveling about 4 to 6 floors per shot, per injection. So let's say on the 6th floor, you have to, underneath the vanity, like you said, we'll take off the supply lines to your sink, and we inject in there through the other 8 floor or the other 4 floors until it comes out on the top. So it's not one shot continuously, it is step by step. Depending on the size of the building, it's step by step, every 4 floors to every 6 floors, depending on the diameter of the pipe and the size of the building. So we do have to go into the units, and we also have to cut the pipe in order to inject every 4 floors. But other than that, there is no intrusion. The nice thing about pipelining is that residents hardly even notice that we're there. There is a manifold that's being installed for the time being that needs to be installed on every floor. Other than that, there is no dust, there's no tools, there's nothing within the apartment, which is a great advantage.
So Mark, your slides are up now. Why don't you go through your slides if you want to, and then we'll come back to questions.
Sure, okay. So this was the recirculating system that I was trying to explain. This is a typical building layout where the hot water up top is the tank, and the hot water is distributing on a main header on the top floor, and then it goes down and feeds all the units, all kitchens, bathrooms. And at the end, on the lower floor, the hot water collects again and gets pushed back up, or pulled back up actually, back into the boiler room where the water gets reheated and sent on the way. So you can see this is a circle, and the water is constantly moving. And the problem with that is that especially the smaller diameter pipes. So a building has, on top it has bigger pipes, and the riser, as it goes down, as it goes further, it gets smaller. The small diameter of pipe is the one where the pinholes usually start. The reason for that is the same amount of water, the same volume of water has to go through a half-inch pipe to the small pipe as goes through the top. So the velocity is much higher on a small diameter of pipe than in big ones. But that being said, the erosion only starts on the smaller pipes, but it keeps going up. If you keep waiting and keep patching the pinhole leaks, you will run into more issues along the way. And the pinholes are starting to get bigger faster just because the thickness of the wall thickness of the pipe is constantly decreasing to a point where you could, technically, we've seen it before, where you could pinch the pipe with your thumb. So this is the recirculating system. And this is the pitting that I was talking about. This is how erosion looks like. We have pipe samples outside also that you can actually take a look at this. It's not an even, erosion is not even. It's Water creates turbulences within the pipe, and so some areas are affected more than others. This is the velocity of the water, and also poor workmanship in some cases, which also affects the cold water. If something is being soldered or has been soldered, a connection, you need acid in order for the solder process to work properly. This acid has to be usually wiped off. Sometimes it doesn't get wiped off, so it stays there. And it is an acid, so it corrodes the pipe from outside in. So that's why poor workmanship is also a factor. It's not as bad as the velocity of the pipe. That's the major cause number one for pinhole leaks. This is the process created. Here you see the hot compressed air, how we clean the pipes and how the pipe is being heated up for the process. The epoxy needs a certain temperature to react properly. Then the air is being pushed through the pipe, so it's always going from the small diameter to the big diameter where the epoxy is applied. So the epoxy gets pushed through on one end, on the bottom in this case, until it comes out on the top. That way it is ensured that everything is 100% coated. After the coating is done, there is a 45 minutes running time in order to make sure that the epoxy is tacky enough to stick without any air. Then the air will be shut off, and the next morning the water will be turned on, and you have a new pipe within the old pipe. The warranty, compared to new copper pipe, this warranty is much longer. The warranty for Ricoh's is 25 years on line pipes. Of new copper pipe, you get probably like 2 years maybe. So there are issues when there's, for example, galvanized pipes in some buildings, in really old buildings. Those pipes need to be replaced. Lining is just not, it doesn't make sense. It would cost too much because galvanized pipes, they start rusting. In order to get the rust out, it takes double the amount of time than it would be lining copper pipes. So I would always suggest 100% if there is rust in pipe, if you have rusty pipes, if you have galvanized pipes, they need to be replaced into copper pipes. Or these days, PEX pipes, plastic pipes are big these days as well. So, and the warranty is much better as well. Now that's it. Thank you very much.
The RHB Insider Network is an RHB Inc. production, publishers of RHB Magazine, and the producers of RHB Newsreel.